So, all right. Sorry guys, took a while. I thought I be a bit daring and try stuff in AWS. Did it last night at 2 a.m. and thought, yeah, cool, it's running. This morning at 7 o'clock, shit, it's down. So I didn't quite figure out what went wrong, and it was a bit hacky. So we'll see if we can make something out of it either way. So some of the topics we still haven't talked about a bit more is like economics of IaaS. Well, it's kind of not what I actually mean with this, but it's really about more thinking about runtime aspects, so operations aspects, if you like, of infrastructure as a service, which needs to be borne in mind. Of course, that's usually a topic that is to be made by, by the operations manager in a wider sense, right? So, but I think it's still worthwhile bearing it in mind, because it may well be a role you end up in. So in reality, you never know what you do. So, so it may be worthwhile just to think about it. And one of the topics, of course, needs to be touched upon is SLAs, right? Did you cover them elsewhere in other lectures or talks? We just want to touch on them very briefly, but I think it's still an important topic to think about, because if you are suddenly in a position to actually form a contract, for example, an SLA. Let's imagine yesterday, sorry, I'm a bit biased here right now. Yesterday was the bachelor project presentation, and most of you, or many of you, were there. And it could well be that a company, actually part of your assessment is actually to run something. And in this case, they may just form a contract and say, okay, this is the SLA you need to commit to, and you actually better comply to it. And if before you sign something, you better want to know what it does, right? So that's roughly the idea. SLA, what does it stand for anyway? Since we're on it.
Service license agreement.
Yeah. Other views? Service level agreement. Right. So that's I think a conventional use. But I think it boils down to roughly the same thing. Let me just check if my stream actually has sound. Yeah, it should have sound. That's cool. Just to be safe. Yeah. So. Okay, if you think about an SLA, right? If you were to be in a position, and many of you have some operations background or even programming background in this context of the class, and you think, okay, I want to run something in a data center, or I want to start my game startup, right? You may well be in the position to actually develop an SLA, right? So and have someone else sign it. So it may also be a situation you may be in. So streaming works. Thank you very much. I hear my own voice. It's so annoying. It's so it's really determined. What should be in there? Date and time, for example. I don't know. What should be in there? So just the ideas. You think about, so you're running, or let's say hypothetically you're doing a game startup or application startup for that matter, right? So and you're endowing someone else with the operation, right? So you as the customer, client right now, right? What do you expect from that provider? What should be regulated in an SLA?
What they can do and what you can do.
Yeah. So what they can do, what you can't do, right? So could responsibilities perhaps, or roles in a way, right? So yeah, cool. What they can do, what you can't do, yeah. So I think let's expand this a bit. The responsibility is also what you have to do and what they have to do, right? So it's not only what they can't do, but also usually it means, for example, if they're supposed to run software, you will want to commit to provide in a certain format, right? So you may say, okay, all software will be provided in a Docker container with Docker file. Or something like this, or as an image, right? Under Docker Hub or something. So you need to define the interface of interaction in a way, responsibilities, right? So yeah, that's one of them. Yeah, what else? It's not super hard and fast. I just want to develop some sensitivity. What do you think should be in there?
I would like to have agreed on uptime.
Cool.
How rare is it? How often is it acceptable for the entire system to fail?
Yeah.
And I also want to know who's responsible for my data if and when it gets lost.
Cool. Right. Let's debug that a bit, because that's becoming bigger than I thought. Okay. Right. Welcome. So let's start from scratch. We mentioned responsibilities. The reason I'm using single words because it's more memorable, so it's easier than having sentences. Responsibilities. And your tag, what did you describe?
What?
What would you characterize? How do you compress whatever you said right now into one word, one bullet point?
Accountability, kind of.
Accountability, yeah. Is there a link to that?
Well, not really. Responsibility is the things you have to do.
Yeah.
Accountability is if and when something goes wrong.
Yeah.
Whose fault is it, and who owes who money?
Cool. You mentioned another term in there.
Uptime.
Uptime, right?
Service quality.
Exactly. That was the term I was looking for, because that's actually one of the core elements, right? If you say service level agreement, then we need to define service quality. And uptime is a typical metric, not the only metric. And another topic of talk, we get to that in a second, but it's also important. Is that somewhat legible there? Even though my pen is dying? Even if it's not legible, it's because of my pen or my handwriting. Anyway, so let's not go down that route, it won't help. What else? So we have responsibilities, we have accountability, so if things go south, what happens, right? So that's actually a very good point, because that's where the lawyers come in suddenly, and then it becomes really costly when your system is still down.
Well, at least for me as an admin, I have to think about accountability.
Yeah.
Things will go wrong.
Yeah.
And I want to know who does what.
Exactly. Yeah, and who ends up in prison as well. Yeah.
Yep.
So it's also good to know. So, or when you end up in prison, so it's very well likely.
I also want to know where the servers will be, especially if it's about very sensitive data.
Yeah.
I want it to be in a country that's covered by GDPR.
Cool. That is a very extremely good point, and it doesn't fit into my bullet point structure yet. So what would you see that as? Is it more like service quality, or I don't know?
Reliability, maybe.
That would be what would be quality. But you're distinctively saying you're thinking about regulatory aspects, right?
It does go under accountability. If they were to lose or leak any of my sensitive data, they would be responsible, at least through the general rules of the GDPR.
Yeah, that's right. So you're absolutely right. Admins and operators have very distinct responsibility with the renewed privacy, right? And yeah, GDPR in particular being pushed down, you need to have an operation statement, right? Where you describe for every website who's running it, what you do, how you do backup, and what happens with the data while it's processed, right? They're actually spot on. So I think let's fit it under accountability, like you say, right? So because I think it fits quite well there. Very good point. So data breaches, where do you store data? Is absolutely right. There was a discussion, for example, I am not sure if you followed that up. That was last year in the news that turns out that the operations, I think on Swedish health data or the like, was actually outsourced to somewhere in Eastern Europe. So basically operations, the people that ran the system were actually sitting in Eastern Europe, but it was actually very sensitive health data. And they hadn't been properly trained, I think, in the privacy, regulations that are necessary. So if you just blindly go by price, that can go really sideways, right? Service level and service quality was not agreed upon in this context. It may well be, but in this case it just was ignored. What else? Is that all? As an admin again, what do you need to actually assess service quality? Or as a researcher for that matter?
Quality, well, there's uptime and there's that's a complete failure. I would also consider it a failure if I was unable to log into the system. Just general reliability.
Right. So you kind of exactly. It's again falls in the service quality some extent, right? You're specifying what, for example, a running system means, right? So it means it needs to be running. I need to be able to log in. So meaning all the ports that are necessary to run the service need to be available, SSH, port 80, 443 or whatever else, right? So and what other aspect could be a characteristic of service quality? Not just only is it there, is it pingable, but also what else? You think about games, in particular.
I should have I would usually have defined how quick would this be? How good is the line into the server facility? How if this is slow, I don't want it.
That's right.
Yeah.
That's right. So you basically so there's two kind of slow here right now, right? So you point towards time.
My fault, and there's a slow that's their fault.
Yep, cool. So, so how do you do that? How do you deal with this?
Well, I would define how it should be.
Yep, how do you define it? Like concrete operationally? If you tell me, okay, this is the service you should deliver, so how do you convey to me that I actually know, okay, exactly that's the service quality I want, you want, in terms of time or performance or whatever you mean?
I don't know.
We need some metrics, right? Latency, right? So you just say, okay, you need to respond with a maximum latency of 100 milliseconds or something like this, right? On average in a 24-hour period usually. It's always on average. If you have a situation down, lack of performance, that's oftentimes tolerable unless you have strict real-time requirements. Then you probably have a redundant setup anyway, right? So across multiple availability centers if with your cloud provider, right? So you would have something in Asia and North America, something in Europe, and so that's another story. But that's right. So latency is a good one. And you also pointed to another form of time. What other kind of time do you expect SLAs to cover?
Uptime.
Uptime is, let's ignore those technical ones. What other kind of time, usually related to humans, would you expect to be covered?
Support time?
For example, exactly. Well, it doesn't help you much if your service is down, like in my case, last night at 12, and your support time is from 8 a.m. to 5 p.m. Cool, eh? Right? Full coverage between that time frame. Not good enough, right? So for most operations purposes, right? So the service time frame, support time frame needs to be specified. And that's one aspect, yes. Something that also need to be specified with respect to, so what other aspects need to be specified in advance? So we have the support time.
Well, what services I can expect.
But it's more like a what. But I want to have more like a how. So in terms of time. Starts with R, perhaps? Response time, right? How fast do we actually get stuff done again, right? So you may specify uptime or not, but sometimes there's other service needs that don't directly affect the uptime, but the latency. But the question is there, how fast do you fix the problem, right? So what's the maximum time frame that I allow you, perhaps an hour, 2 hours, I don't know, half a day, 1 month, to actually fix that problem, right? They say, oh, we're on it, it was covered by the SLA. You used to just say we need to address it, right, within reasonable time. What's reasonable time? I think 1.5 months is totally sensible, and we work between 8 and 5. Remember, right? So that needs to be specified as well. What's the response time there? Classic other issue is, but this is a very practical concern, is means of contact. That's the classical problem. So they actually, so if you have a service request because you experience downtime and the like, and they didn't respond to you, it could be an excuse to say, I used the wrong communication channel. That was not agreed upon in the SLA, right? So do you need to use the ticketing system? Can you call them up? Do you do it by email, Discord, So this needs to be negotiated as well, because those things suddenly become sensitive. When it's really about playing the blame game, then it suddenly boils down to those things, right? We'll only consider your the response time after we actually formally notify us by telephone. Not tweeting, hey, my service is down, shitty provider, hashtag I hate my provider, right? So that is probably so that's probably not helpful, right? So so communication channels also need to be provided, right? So it needs to be specified as well. One very clear aspect there. Cool. I think we roughly got something together here. So that is all under service quality, basically. But I think the time aspects, the temporal aspects are quite central, right? Time-bound aspects. You don't just specify time, you just say what's the maximum time periods, in terms of response time and so on, that you permit as part of your SRL. You want to quantify everything as far as possible, not within reasonable response time. That's usually a legal text coming along with this. But in operations, we kind of like metrics. So make it as many metrics as possible. The other thing is also, okay, who is responsible for which metrics, right? So there may also be an expectation that you, as the customer, for example, system is down, and the service provider asks you questions. There may also be a response time on your part. They may actually expect you to respond within 5 minutes to potential inquiries they have to you, right? So that's the reciprocity issue, right? And if you don't respond, you breach your service level agreement with them to some extent, and suddenly, or at least they feel they may not be held accountable anymore for breaching their part of it, right? So it's kind of an interesting one. Any other things that probably should end up there?
Consequences of breaches. Some breaches are less fatal than others. Well, a breach in service quality would probably, to some extent, I forgot the word I wanted to use, but you would want to terminate the contract entirely and just switch providers.
Yeah.
Other things, if it's slow, sometimes you might want to get like a discount on next month.
Perfect, right?
Like that.
That's a very good point. So it's clear we have accountability to some extent here, but I think penalties are really important, and perhaps also who enforces them, right? So do you, for example, manage that yourselves amongst you two, or do you use the legal system, right, to enforce penalties? You say, okay, I make the claim that I get a discount 20%. The other guy says, well, but who is actually responsible for enforcing that I actually give you the discount, right? So is that specified or not? Or do you need to employ your lawyers, which is money, right? So you may be, you probably just wait another 24 months and change the provider after that, instead of, engaging your lawyers just to fight for a 20% discount if you don't get it. So it should also be quite clear how enforceable things are. It's good to have things on paper if your provider is somewhere, I don't know, because it was the cheapest one, close to Antarctica, because they don't have issue with the cooling. But you actually can't get hold of them, when you need enforceability, forget it, right? So unless you drive down there anyway. Yeah, so that was one. The other perspective you mentioned is spot on. This is one set of requirements. When there's there's very general points here, but you can derive more specific requirements that are found in SLAs from those ones. But the one I like really is what is a code red, right? So it really depends on your operations. In a hospital, a code red is something very different from your privately hosted WordPress account, right? So if you have an hour downtime in a month, you have what? I mean, no one cares, right? I mean, it's not a big deal. If you're an hour downtime in a hospital, that's a biggie, So you may be able to afford this if your IT is down there, right? So you need to specify what are different stages, right? What's the code yellow, and what means all systems are operational. Perhaps even there's a tolerance towards failure to some extent, right? So what really constitutes different states of system brokenness, if you like, or availability in the widest sense, right? So that's important. So it's so to bring it all a bit together. So the first thing, of course, is important to define terminology, right? And also what you're responsible for and what not, right? So we have the issue, or the principle of force majeure. So if, for example, there's an earthquake, avalanche, or sandstorm, I don't know, you name it, right? Any of the major forces coming into play, right? God's hand, if you like. So, in how far are you as a service provider still responsible for those issues, right? That needs to be defined as well, right? So, of course, they can eat into your downtime if you like, but there are things you can manage, things you can't manage, right? So, perhaps you recall last year even Amazon was down for a considerable time, right? But what you do, if you are using Amazon as your cloud provider and you're providing services on top of it to your client, basically as a reseller in the widest sense, there's not much you can do, right? So unless you have a strict service agreement with them, and if they are affected by some sort of natural event, then there's little you can do. So it needs to be quite clear. Then, of course, downtime. Different stages of breakage of the system. So what's the code red, for example? Things should be as measurable as possible. Try to put numbers everywhere, because then it's easy to argue, right? Super clear. If I have latency, if I have throughput, I/O per second, for example, that your system needs to provide. If you're thinking about number crunching, So any sort of metric you can think about, right? So response times and so on.
Also, who keeps the metrics? I assume that both parties would be measuring this stuff, and often they would disagree.
Yeah.
Oh, so we found your latency to be like 300. It's too high.
Yeah.
No, you're wrong.
Yeah.
we have perfect 100 latency.
Yep.
It Mostly on your end.
It's also that's right. That's one thing, and also quite practically it is okay. I mean, your point is perfectly good. It's absolutely spot on. We get back to that in a second. Where do you measure latency, right? So, for example, do you measure it at the network entry point, or do you measure it at the host, right? So you have a virtual host. What's the latency in terms of response there? Measured from within that virtual environment here, right? Or do you measure it outside of the provider's, from outside of the provider's boundaries, right? So, absolutely right. So, where do points of measure? Yes. Absolutely, good point. Probably should be added here. Actually, that's probably more like context, I guess, to some extent. But I really like this injection. It's really good.
When it comes to latency, well, the provider would probably, I suppose, have an agreement with their ISP, trying to guarantee as low latency as possible.
Yeah, and just ensuring that their penalty is higher than yours, so actually earning on their failure.
Yeah, but that's how it works. Everyone has if one company is being held accountable, they will hold someone else accountable.
Absolutely. That's the price you pay in this integrated system. Yeah, absolutely. I mean, as a service invites you to basically rely on others anyway, in whatever way. And yes, you need to have those mechanisms. So the point is, you see that SLAs can become incredibly important in that context, right? To get them right in a way. Please.
Yeah, I'm just following on Wikipedia, and it says that Cisco has done some attempted to have some neutral standards on how to do measurements.
Right.
So you can use those standards to say publish for SLA.
Yes, but remember Cisco. Cisco is not a neutral, standardization organization in its own right. It's a bit like.
I mean, Cisco, sorry.
Yeah.
They might think they are sometimes.
But I agree with you. I mean, they are a big player in particular in network gear provision area. Absolutely, they're the number one there. So it's sensible that they do this. That's right. Yeah, that's a good point. So see what standards are out there. It may actually be of help to you. But so that's a good point. So measurability wherever possible, specify context. That's right. We talk about responsibility, who does what and when and so on. So time-bound aspects, of course, response time. But it also needs to be realistic, right? So if you promise something, you better ensure that you know how to deal with this, right? If it happens, right? So you can't just say, I do 99.999 uptime, guaranteed. No big deal. Here's the cheapest price. Go for it. So you need to see that they actually can satisfy it. So it's quite important, dealing with redundancy and availability and things like this. So it needs to be on both sides. Can you assess that your operations provider can actually do what they promised to do? Please.
When discussing these things, is it normal to have a representative of the engineering team because talking to a pure salesman does not work. A wise man once told me a good technician can never be a good salesman, and vice versa. So.
Yes, that would be desirable. I think it should be a tech team, right? So you have for example, the director of the data center or CIO or something of the company along with you, unless they don't have a CIO, which is kind of weird. But then you probably should have someone from the field as well, yes, ideally. But in many cases that's simply not done because they kind of want to make it down simply and have often a price-based decision. But it can also be the other way around. They basically say, okay, we have a rough specification that they lay out, and then they take it, they give it to engineers for revision. Right, so basically send around the amongst the team and say, hey guys, do you have comments on that one? And then bring it back to a negotiation table. So it's kind of a staged approach that you have the internal assessment and the external one. So which is sensible as well because you're not swayed by biases. You're just very clear. Okay, what do we actually need? Right? If you basically ignore the price, you just look at the characteristics and say, yep, that works for us. Or no, we need to actually change something here and then give it back to a negotiation table. So it's both aspects are possible. The scary bit is probably that people just negotiate without thinking about the deeper levels. In fact, if you study things like information management, though, they actually kind of directed towards knowing those things. But still, I agree. Even though they have a bit of a IT background, they're usually not as deep in the material as the actual engineer would be. So I agree, it would be desirable either to be involved directly or indirectly in shaping such an agreement. In fact, what I did in my previous institution, have my students provide such an agreement. So to me, I was the product owner, right? So and I was trying to break the system, and I say, okay, we make an SLA, see how it goes. And that was a good lesson learned, because it was really evident sometimes that things hadn't been thought through, right? So and the latency one is really a good one, right? Who measures what? Things like this. Of course, things go sideways, and you need to, however, also know the lingo, right? So on both sides. That's right. Cool, so time-bound realistic, and again, what I really like is the penalty and enforcement, but also one characteristic is review, right? Does, for example, service level agreements have annual reviews, right? For example, your performance requirements may change over time, right? So if you're bound or locked into a service level agreement for 24 months, that may not be in your favor, right? So so it's a bit like in the beginning 2000s, if you would have gotten an ADSL account, right? You're locked in for 2 years. By that time, it's so slow, relatively speaking, that you would hate yourself for having ever signed this kind of agreement, right? So and the same thing applies here, but here it's just more critical, because that is your startup that is trying to scale, and suddenly you can't meet, you can't play the game because you have not enough uptime or reliability or whatever else, and your competition is simply better, right? So things are moving, so it's important to bear that in mind as well. Cool. Yeah, so does it make sense somewhat, thinking about those things? Right, so just to bear that in mind. Of course, doesn't mean that you're writing one tomorrow. It's really more like, okay, if anyone puts this thing on your table, or puts you on a table where you actually need to discuss about this, you should have some starting points of thinking about it. So the SMART criteria, which is a bit of a dated concept, it's not related to SLAs per se. It's actually management principles, how to manage, agreements within a company. That was the key idea. It could also be just, your progress report with your employer. So it has the same characteristics. What is the context of your interaction? What are metrics that you're applying? Who does what? How realistic are things? And what are the expectations on either side? What are penalties involved if things go sideways, right? So but it applies here very well as well, right? So it's very uniform. And there's a lot of templates for different SLAs. So it's if you're in this role, it's of course worthwhile looking at that. So, coming back to you, it seems to you you're my conversational partner here, so for now we need to change that a bit in the rest of the lecture. Yeah, uptime. How much 9s do you need?
As many as I can get.
As many as you can get, yeah. Why?
Well, I want to have a reliable service for my customers.
Yeah.
And also, if my provider has 90% uptime,
yeah,
which would be the theoretically maximum you could expect to have, so they will have errors 10% of the time. My software and my service will also have errors 10% of the time, and so depending on how many levels we have, the end user might have much less than 90%.
Okay. Right.
Because I will have errors.
Right.
When they have. When they don't have errors.
Yeah. I see what you mean. Right. So in this case, it probably makes sense to outsource the entire operation, because then they're only completely responsible for 0.9s. Yeah. But you're right. So from a user perspective, it can accumulate, right? So you have a different network provider with whom you have a service level agreement. Then you have your cloud provider. You have a different service level agreement. They're all 0.999, right? So you yourself have an internal agreement, if you like, with your operational staff, and suddenly this accumulates because all those margins, pile up to be considerable downtime. Yes, that's right. So it's a good point. Yeah, but what's sensible on average? If you say, okay, I have this deal here. How many 9s do I need by default? What's sensible?
Isn't that determined by finance?
Yeah, but I think. Of course, but let's come back to the engineer perspective in a sense. What I intuitive, if you see those numbers, 90%, right? Is that a lot? Is that high, or is that not so high? How much downtime do we have there, roughly?
Well, that's what I was going to say.
Yeah.
I was going to state that
please.
Pretty much depends on what kind of program you're making, because having 30 days a year, 36-ish, downtime is acceptable for some services, but not acceptable for others.
Yeah. So that's right. Yeah, your point.
Yeah, I'm just trying to think say that I think 90% downtime is a lot. For some sites, for example, if
50% down.
no, I mean uptime. Sorry, yeah, 10% downtime is still a lot because in a day, for example, it will be down 2 hours every day, for example. If you have something, so that's gonna be like, for example, if you have like Twitter down 2 hours every day or something, it will be quite annoying.
Yeah, that's right. No, you're right. That's actually 2 hours down. Shit, I got the metrics wrong, so ignore that. What happened here? Yeah, this one is off. That's right. Actually, per day, that would be like 2 hours down, right? So 90%. That's not cool, right? If you think you have 21 hours something availability, that's probably not cutting it, right? So I put some metrics up there just to give an intuition. If you have a 99% uptime, you probably daily have 14 minutes downtime. That's quite a lot. 14 minutes. I mean, you know, if you just think intuitively about it, there's a decent probability that you're hitting F5 and your page doesn't, you know, refresh, right? So, and over a year, that means like 3 days, right? But of course, it goes incrementally down, and then the prices go up. But even if you think about this one, I mean, 90.29, they still have, you know, daily 9 seconds on average of downtime, and yearly it's nearly an hour of downtime. So, can you afford this, right? Right? If you, for example, media production company, right? So you're streaming Netflix style stuff. Probably not acceptable, right? So having an hour downtime per year is probably not good for your business, right? So if it's this university, yeah, whatever, right? So no big deal. We cache stuff and then the emails get delivered a bit later. And streaming is outsourced to YouTube anyway, so that shouldn't be a big deal. So that's really the idea. So you need to kind of make this trade-off, because intuitively many people will say, 99.9 will do, right? So that sounds about right. So it's fairly, you know, it's like nearly 1. So let's still work with this. But actually on a yearly basis, it's, you know, a work day offline, right? So it's quite a bit actually, if you think about it. So it's just to challenge the intuitions that may lie behind it, right? So even if you have 4 nines, right? So you still have half a minute of downtime per year. Oh yeah, well, yeah, you know, so it's just a matter of what you want. But we're not done with this. What is downtime actually?
Well, there's one or all of the systems would be one or more or all of the systems would be inaccessible.
Yeah.
Like a website could be up, but the login system might be down. The databases might be down.
Yeah.
Stuff like that, like especially in gaming, for example, the service, the game might be up, but the login system might be down.
Yeah.
For some time.
Yeah. So you're decomposing the system and saying, okay, downtime means if any combination of, you know, all the services is not up, it's down, right? So you say, well, if the login system is not working, even the rest is working, I don't care, that's downtime for me, right? Is the intuition I get? Well,
then I'm actually cutting downtime for each and every component. So.
But then you accumulate downtime, right?
Yeah,
so
it would accumulate.
So yeah, well, that's probably one. I think realistically, you would just say which components can fail without affecting the uptime, right? So if there's any, for example, a logging component, if that's down for like, you know, a bit that may not be super tragical, it may be code yellow or something like this. But if the login system's down, yeah, that's probably it. That's probably really considered downtime in the hard sense, right? So you're not meeting your service level agreement requirements. Yep. So, but more technical now, because we need to think about providing the cloud services, especially if you think about AWS. How do we assess downtime actually? How does it work?
Planned, non-planned downtime.
Aha, what's that?
Frequent is planned.
Oh, aha, we have another dimension here. Right. So there's planned and unplanned downtime, right? So we need to bear that into account as well. Does that eat into your uptime requirements? Well,
I think often planned downtime is not measured.
Exactly. Generally, planned downtime is explicitly stated in the SLA and say, you know, it's not part of the downtime measurement. And then, of course, the secondary metric: how much planned downtime can you afford per year, right? If you have 360 days planned downtime, then you have a very high availability. That's a good deal you can make there, but I don't think that satisfies any customer. So that's right. So planned and unplanned. What else? But concrete, how do you measure, you know, uptime in the first place? I mean, you have the machine running there. How do you measure it? How is it done? Ops people, come on. Anyone? How do you measure it? How is it measured? Practically, you're sitting there. You have a server.
if you're able to well, use the service
Yeah.
nominal capacity.
And how do you assess that? Well, it's not you pressing F5, right? So hopefully, if it is, then it's a very expensive mechanism of assessing uptime.
Well, if you want to test that, you would have an automated service doing it,
That's right.
checking.
How does it do it? Yeah, yeah. Continue. You on the right track? You
Yeah,
have not.
it would run a script that, well, if it's a website, it will just simply curl it, see what content you get.
Yep.
If you get any useful data from blah blah blah.
Yep.
Whatever.
Right. So you're on the right track. So generally you would use something like monitoring software, right? So I think Nagios, things like this. Has anyone come across those things? No? It's cool. So yeah, cool. Right. So it's basically professional monitoring software that allows you to specify uptime requirements, and things like this. But if you set them up, what are you constantly checking for uptime of services?
No,
Why not?
because such a test would have to test everything, and it would be a huge strain on that machine.
Any test, especially putting load on your system, right? So you need to kind of deal with this trade-off, right? How often can I actually test for availability without actually putting 50% load on my system by just monitoring the system, because you have a constant interaction to measure both latency and availability of the system, right? So realistically, what happens?
Well, you might check every 5 minutes.
That's right.
Which then begs the question: how long downtime would actually be downtime? If it's less than 5 minutes, is it downtime at all? Maybe not.
Well, that's precisely the point I want to get. So the problem is, if we're measuring uptime in general or system, then we are measuring it in time intervals, right? So, and we kind of approximate the availability to some extent, because we can't measure more often. So if you do in AWS, by default, they measure, at least from a user perspective, internally I'm sure they do it more often, every 5 minutes, exactly like you say. So default setup. If you want to have more frequent observations, you pay for it. As CloudWatch, usually it goes down to 1 minute then availability checks, but it's quite expensive. So monitoring is actually expensive on multiple dimensions. Of course, number one, actually paying for the service, somebody doing it. Number two, you're paying for the resources, and the resources are used, therefore you pay more for your resources, right? So because you pay by process CPU cycle or by network throughput, and that's suddenly something you need to pay for as well. So monitoring is expensive. But what I want to get at, usually if those systems measure, they have a kind of a staged approach. So you basically measure every 5 minutes, right? And if you get a ping back, right, then everything is okay. That's the confirmed uptime. Everything is good. Then the past 5 minutes are considered up, right? Okay. We have the next time frame, right? This window there, and then you do the next check. So if after 5 minutes the next contact fails, is that what is happening then?
Well, I suppose the downtime starts from the test descended, and
so yep, that's precisely often the question there, because it may also be just other infrastructure interfering with this, or packet loss, right? So maybe all one aspect. So what usually happens is that they have a stage retest. So if there's a reliability, so for a server's not responding within 5 minutes, then they will do another test within 30 seconds or 1 minute. So it goes down the testing frequency, so it's more frequent to assess. And the second or third test, usually 3 tests, to confirm up or down. So that's the confirmation, and that's the challenging bit. So in this, if your machine has been up and you have an unconfirmed down, so meaning your machine hasn't responded, but you're yet waiting for another confirmation that the machine is actually down, is that considered an up or a down, right? So and that's the question, because it usually boils down to what the final assessment of the confirmation will be. So you're retrospectively assigning whether your machine has actually been up or down depending on the last check's outcome, right? So that's the key idea. So it suddenly boils down, if you have an unconfirmed up, it's considered up. If you have an unconfirmed down, it's still considered up. So meaning if the down is not confirmed, if the down is confirmed, ultimately then it's considered down. And if it's unconfirmed up, but the system is actually down, it's also down. So this is the kind of thing to bear in mind. So checking frequency, and what happens if a system is actually, how is a downtime or uptime confirmed, right? So that's the key idea, and it costs money. So if you think about the SLA, you kind of want to think about this as well. Yeah, because suddenly if you only check 5 minutes and you have an availability of, in this range here, you know, one failed check would basically imply that your yearly quota of your 0.999 is actually used up already, right? So that's why monitoring is kind of totally important to interact with these uptime requirements that you are having here, right? If you're checking infrequently enough and it happens so that you have an unconfirmed down and the system is back up by the time you're checking again, then it's considered uptime, right? So your system was technically actually down, but it was an unconfirmed down, and it was just long enough because they tested every 10 minutes, and the system was back up by that time, so it's in their favor, and they get away with this, right? So it's important to be aware of this as well. Checking frequency. So if you have high frequency requirements, you need to do simply more monitoring, and that usually costs more money. So there's a trade-off there. And again, on both sides, both actually paying money, but also your systems will have more load. And since you pay by load in cloud environments, you also pay more for that. Cool. Kind of makes sense? Yeah, just things to think about for you on your part in particular.
Also,
yep.
Quality would be if we say that any time shorter than 5 minutes is not really downtime, but what if for some freak reason the system goes down for 10 seconds every 30 seconds?
Yeah.
Then the site has 100% uptime, but
exactly,
it's not reliable at all.
So
there's no service quality.
Yeah. So that may be absolutely, yeah, exactly. You're right. So, you know, so that's where the monitoring system comes into play, right? So if you, for example, provider side one and they have certain guarantees, and if you're saying I'm paying for the service anyway, so I can define my own monitoring system, spot checks. You can do it externally, and they conflict. Then you can suggest that your checks are taken into account as well, if you provide a proper log and so on. I agree. Yeah. So that's definitely something to simply bear in mind, right? So when you're thinking about designing such a solution, are you in a position to do that? Problem is, last night I was mucking around and trying to get some scalability going in AWS, and you quickly fake it by having CPU load, but if you want to do it via network load, you quickly get into the issue that you're actually breaching their terms of service, because it's considered penetration testing. Meaning what I'm saying is, if you do too much monitoring, it may also breach some sort of service on their part, right? So they're actually not allowed to implement your own monitoring. So suddenly you have this kind of issue as well. How often are you allowed to actually, test your own system in the widest sense, right? Or monitor, for that matter, your system, right? So, because again, it's load on their end, even though you're paying for it in that particular instance. So just bear that in mind. So I decided not to do that yet.